So I'm delighted to be moderator for this panel. So as Sue says, I'm the director of the UK's Science and Technology Facilities Council Hartree Centre, and I'm based at the Daresbury National Lab. So Hartree Centre is a supercomputing centre which primarily works with UK industry, companies of all sizes, looking to improve productivity through the adoption of high-performance computing, data analytics, and artificial intelligence technologies and expertise. So I'm joined by three knowledgeable and opinionated panelists. So UK HPC strategy is a topic very close to all our hearts, so I'm anticipating a lively discussion. So the first panelist is Dr. Ben Bennett, who's Director of HPC Strategic Programs at HPE, and he's got over 30 years supercomputing experience in academia and industry, both as a supplier and purchaser of high-performance computers. So Ben's working to drive supercomputing content and knowledge into all of HPE's work with science, research, and industrial components of public bodies, both at a national and a European level. Our second panelist is Mark Parsons, who's a professor of high-performance computing and the director of EPCC, the Supercomputing Centre at the University of Edinburgh. So EPCC hosts a number of the UK's national HPC services, including Archer and Archer 2. So Mark is also chair of the UK's Exascale Project Working Group and director of research computing for the Engineering and Physical Sciences Research Council. Our third panelist is Daniele Piccarozzi, who is the Senior Business Development Manager responsible for the EMEA HPC business at ARM, a British semiconductor and software design company supplying technologies used in all areas from IoT to data centers. So during his career, Daniele has been involved in design and deployment of some of the largest HPC installations in Europe for scientific research and industrial applications. So I'm sure you'll agree with me, an excellent panel. So we'll crack on to addressing some of the questions. So I'd like to address the first question firstly to Mark. So Mark, what does and could HPC bring to the UK?
So I think, thanks very much, Alison. Thanks for the introduction. So I think HPC is one of these topics that actually has been with us for a long time. You know, it grew up from the beginnings of computer science in the 60s and 70s, and it's always tried to be right at the front end of the capability of what we can get computers to do. So the definition of a supercomputer changes all the time, and it's just the biggest, the fastest, the best computer that we can have. And over the last 20, 30 years, pretty much every plane you fly in, every car you drive, every train you're on has been modeled using high-performance computing, supercomputing applications. It's just absolutely fundamental to our lives, and yet it's something that the general population really knows very little about. But modeling and simulation is absolutely fundamental to so many aspects of our lives nowadays, not just on the engineering side, but also in terms of biomolecular modeling, materials modeling, thinking about climate change, obviously, and all the modeling associated with that. So it really is one of these areas that just spans so many parts of our day-to-day lives, but in some ways is slightly hidden, but it's fundamentally important to the UK.
Okay, thanks, Mark. So Ben, you've been working in the industry for 30 years, as you said. So what could you like to add? You know, what are your views about the importance of HPC to the UK?
So HPC is not just about the technology. It's the fastest. It's the biggest. It enables us to experiment in ways that you physically cannot. I mean, we cannot experiment with weather. Weather tends to experiment on us. You know, the very large supercomputers today are based around technology evolved within the US to prevent nuclear accidents. But as a supplier of technology, one of the other things that this pursuit of supercomputing excellence does is it pushes down technology to the masses. So the very, very, very powerful supercomputers of today and the technologies required both in software, interconnect, memory systems and processors, that starts to push down the supercomputing food chain to impact the computers that you use every day. An example of this is obviously the cluster technology that came out of the work done in the late 70s and early 80s, that all of the computers in the background that support platforms like this, your mail systems, are all just large parallel clusters. And that is a direct impact from the research to generate supercomputers.
Okay, thanks. Daniele, you work for ARM, which is clearly a fast-growing company and one of the ones which is now heavily involved in HPC. So what's your views on the importance of HPC in the UK?
So as Mark and Ben said, HPC is not just a tool for science, but is something that gives a big impact on our lives. A lot of products that we use are actually designed using HPC, and having a healthy HPC ecosystem means basically better research and stronger competitive advantage on the global market. And when I talk about ecosystem, I don't just mean infrastructure, but I mean all the software development and people working in this industry that makes this very important for this country.
Okay. So clearly we're online because of COVID-19 and the inability of meetings to happen in person. So COVID-19 has provided many opportunities to demonstrate the power of supercomputing. To what extent do you see what's happening now impacting on the future demand for HPC provision and services? So Ben, what's your view as a representative of a global company?
Yes. So as a company, we have sold, deployed and support many of the world's largest supercomputers. And with supercomputers comes expertise and applications people. So we've been working with the supercomputer centers to support their work on drug discovery, modeling, the use of AI to look at numerous antibody detection patterns. What we're starting to see is collaboration. What we're seeing is that the global pandemic requires a global response, and people here in Europe are working very closely with the large American systems. People in Asia are working together. So if one thing's come out of this, one positive thing that's come out of COVID-19, it's been the collaboration and getting the channels open, and the fact that science has no political boundaries.
Okay, so Daniele, does that reflect your experiences at ARM?
Yeah, and one interesting thing about the response to COVID-19 is that actually there was an increase in financing for HPC, especially in Europe, because basically a broader audience, including political ones, basically understood that HPC may play a very important role for these kind of emergencies. So at the beginning, I thought to see some kind of reduction in HPC financing because of will to use money somewhere else. But then I realized that this situation actually gave more visibility to what HPC is doing, and actually resulted in a rising in funding for this kind of system.
Okay, thanks. So Mark, as one of the people who's planning for the future of the UK, do you see this as having a positive influence on future planning?
Well, it certainly can't do any harm. I think it is, in some ways, the COVID-19 crisis has been very interesting, because you might have thought a year ago that actually science wasn't terribly important. we've moved back into a position through this that, you know, every day government ministers in Scotland and in England, in the UK, have relied on the advice they're getting from scientists. And I think from a scientific point of view, that's great. It's really, really positive that people understand the value of the work that is done. I think specifically with COVID-19 and supercomputing, it's been very interesting. First of all, the number of systems that have been made available to do modeling of different aspects of the virus. So that goes from the biomolecular side of things, looking at how different drugs can affect the virus, trying to understand the virus itself, all the way through to the modeling that people have done around the R number and how it's spreading through the population. And I think that does help to make the case for greater investment in high performance computing. And it's also useful to look at what's happened over the last few years in other countries. For example, the fastest computer in the world today is Summit. That does 200 petaflops, 200 million billion calculations a second. And the sort of work they've been able to do on that computer is just stunning in the terms of its complexity and scale. And it's something we should be aiming for in the UK and Europe.
Right. I think that leads us on to our next set of questions. So I think we're all in agreement that COVID-19 has been an opportunity for supercomputing to demonstrate its continuing importance to the UK. Where at the moment do we see the UK in the global supercomputing landscape? So perhaps starting first of all with you, Daniele.
So this is an interesting moment for the global supercomputing landscape, and we see that each country basically is taking its action to reach the exascale system, the first exascale system, which will be basically the next generation of supercomputers. And what I see here is that there is a big focus on co-design. I mean, we lived in the past 10 years in an era where basically we had more and more core every year for each socket. So basically you have the industry, the HPC industry, the semiconductor industry, able to provide more compute power per system year after year. And now we are reaching a point where this kind of technology advancement is in somehow slowing down or being much more expensive, and the industry is looking at some kind of optimized system. It's looking at some sort of architecture that can exploit at the best the potentiality of the software, and this is achieved mainly via co-design of software and hardware. So the approach of not designing a system looking at its peak performance, but looking at what it actually needs to deliver to the society and to the research community. And we have a good example of this in Japan, an example where the Japanese government recently came out with what is currently the most powerful HPC system in the world that has been actually designed with this kind of approach. And European Union is doing something similar with its own EPI project. And I think this is really the path to go here forward for the design of these systems.
Okay, thanks. So Mark, you've participated in a large number of international projects, both in Europe and further afield. So what's your view of where the UK is seen in the global supercomputing landscape?
Well, I think at the moment we're viewed with some pity and horror, to be quite honest. If you look at the Archer service, it's now been running for 7 years. While it was, I think, around the 20th in the world when it was first delivered, we're down in the late hundreds now. I think about 270 to 80th in the world. Now, it's not, supercomputing isn't just about comparing one against one's competitors, but it does mean that our industrial companies and our scientists that use Archer don't have the same type of resource that the researchers around the rest of the world have. So, you know, Archer's peak performance is about 2 petaflops. Summit is about 200 petaflops. That's a factor of 100 difference. And as countries like, you know, Daniele was mentioning Fugaku there, the new Japanese system, which is not yet been released, its actual numbers will probably be about half an exaflop, we think, when it's finally published. that and the systems that are going to come to the US next year and Europe in 2023 are completely going to eclipse what we have in the UK, even allowing for the fact that Archer 2 will be about 25, 26 petaflops. So it's interesting. I don't buy the whole arms race thing of supercomputing, but I do buy that our competitor nations are going to have capability that we will not have in the UK.
Okay. So Ben, obviously HPE has a very large percentage of the market share globally. So what would you like to add? Your observations.
So I'd like to pick up on both what Daniele said with respect to co-design and what Mark said about an arms race. It's not an arms race. What we are in is to set an expectation for the science and the work that needs to be done. And there is competition. Do we want to have large machines like the US for doing doing nuclear stockpile work? Possibly not. They generate a special machine that does a special thing. Would we like the investment for a machine that Japan has? I'm sure Mark would agree with me. It would be very nice to put half an exaflop machine in this year, which has the capability, which is fundamentally designed for general purpose science. But the requirement was for a machine to give Japan expertise to understand climate. The original first one of these machines was called the Earth Simulator. Japan is very reliant on understanding its place on the Earth with its issues around tectonic instability. But if you look at within Europe, if you look at, say, Germany, they build large supercomputer systems to support their industries. They have currently 3 machines running, all of which will be faster than Archer 2. And those machines are dedicated to specific areas like the work against industry. They have areas against science and health. So it's not an arms race, but it's about providing machines to support science and research. And I believe that the very rationale for an exascale within the UK is not based on an arms race, but it's based on the case for science. These are the things that we would like to be able to do to remain competitive in the world. And to do those things requires a machine that is at least 50 times more powerful than the machine we are about to put in. And so it's not waving a flag and saying we have the fastest machine. It's a case of this is the science that needs to be done. This is the engineering that needs to be supported. And if we want to remain competitive, to stop our sliding universities down the global tables, to allow our engineering companies to compete globally, then this is the type of supercomputing infrastructure that we need to put in.
Okay, so I think everyone has made some very valid points about how positive it would be for the UK if we were able to increase investment and use supercomputing to its full capability to support all aspects of work in the UK. So I think to pick up on some of the points, and I think I'll start with Mark here. What will happen if we don't increase investment in UK HPC? And sort of why isn't Archer 2, as you've said, a big new investment? Why is that not enough? And why do we have to work on business cases and to be looking forward to exascale in the UK?
Well, I think there's an enormous amount of history here, which I don't particularly want to go into, but Archer 2 is arriving 2 years late. So if it had been delivered around 2018 when it was originally planned to be, a 750,000 core system in 2018 would have been, extremely impressive. And it's still an impressive system, don't get me wrong. I think one of the really interesting things is that it becomes the perfect stepping stone to an exascale system. If we think of Fugaku, which has got about 8 million cores. By 2023, maybe slightly later than that, we think there'll be ARM-based systems with between 4 and 5 million cores that deliver an exaflop of performance. So that just shows that Archer, if you're working in that sort of technology space, Archer is the perfect stepping stone for people to prepare applications, understand how you tame these very high levels of parallelism. I think if we stay, though, at the current level of funding for Archer scale systems, and the hardware component of Archer is £48 million of hardware. If we stay there, then British scientists will go and do their science elsewhere. Now, some of them will leave the country and go and work in the US or Europe. Some of them will simply get their resource elsewhere. But that means that the UK as a whole will not be doing the sort of computational science that is available to scientists in Japan, in Europe, in the US, in China, in even places like Russia, etc. So we will be going down the tables in terms of our ability to deliver modern science and industrial research, without a shadow of a doubt.
So Ben, there's obviously very large computers elsewhere in the world. So to pick up what Mark said, does it matter if our scientists have to access large systems elsewhere? What are we missing out on by not having these systems in the UK?
So if we had 100 exaflop machine in the world and everybody had access to it, that still wouldn't be enough. And what we need are people who understand the science and the applications. And it's the support infrastructure around these very large machines, which is of extreme value. It is the ability to take codes, to take problems, to scale them, to get them working better. And by better, I mean produce more accurate results faster, consuming less power. So this requires expertise. And no, it doesn't matter physically where the machines are, but supporting these machines are jobs and people and scientists and researchers. And if you take the machines away, you take away those jobs. You take away the proximity to the technology. And so I think that Mark would agree with me. Most machines are entities on the end of a piece of wire, but it's not per se the machine that really matters.
Okay. So I think, Daniele, you talked earlier about the importance of co-design. Do you think that UK investment in systems is essential for the UK to be involved in co-design, and how does ARM see these partnerships working?
Yeah, absolutely. I mean, this is a quite important moment in HPC, because we are seeing a shift in paradigms in how you design HPC systems. So this is a really important moment to start working on that kind of activities. And I mean, not doing that means basically not being ready for the next generation of HPC systems that may be much different from what you are seeing now. Of course, ARM is open to collaboration, and we actually do collaborate with universities and our partners on this kind of activities here in UK too.
Okay, so Mark.
Alison, can I jump in at this point?
Yes, of course.
Just to follow up something Ben said, I think, to put this in the real world scenario, I think most people, when they watch the weather on the BBC at night, assume that the clouds they show on the screen are modelled. Actually, the Met services worldwide today do not model individual clouds. They don't compute the weather at that resolution. So they average out the amount of cloud in the sky, but it's not individual clouds. Whereas we all know that the weather comes from clouds. So as we move towards more and better modeling, certainly the exascale era will bring most weather services to the point where they can do clouds for the first time. That's really, really important from a whole variety of things, not just to do with farming, but to do with how much ice cream Walls should be making. I think that people often think that we understand a lot about this area, and actually we're just in the foothills of what will be possible. And simply having a couple of worldwide exascale systems, like you might have one big particle accelerator in Geneva at CERN, isn't the right way to think about this. These are capabilities that every large industrialized country should have at least one exascale computer in it.
Okay, so to link all these responses with some of the previous discussion as well, we've talked about the systems that we have in the UK are very much geared at the moment towards modelling and simulation. We all know that AI is becoming increasingly important. So what do we see as being the role of traditional supercomputing in supporting all these emerging AI applications? So I'll perhaps start with you, Daniele, because I know this is something that's central to ARM.
Yeah, exactly. So I would not see HPC and AI as two different things, but I would look at AI like a particular case of HPC. I mean, if we look at the infrastructure and techniques that you need to process AI workload, you find that it's very, very similar to what you can find in an HPC data center. So you need a lot of compute power, you need fast access to data. So we really are looking at something that we can see as a particular case of HPC. Now, AI is a good example to comment on the fact that what we are seeing is that workloads are not anymore confined to the data center. So AI is a good example because you need to run AI workload not just in the data center, but you want to run that kind of workload also on the edge, on the device, or on the edge of the internet. So this is another trend that we are seeing. So the need to be able to process data across all the spectrum from the edge to the data center, and this is something that we will see also for traditional HPC, as long as this need to process data becomes more and more important. An example in managing IoT and in the industry 4.0. So I would really look at HPC and AI as two faces of the same coin, basically.
Okay, so moving on to Ben, is that the view, your view, and the view of HPC, that it's very much interconnected?
So I'm going to separate the corporate view of HPE and myself. I think if you want the corporate view, you can read the website. Okay. Well, we'll start with a brief corporate view. Is that we believe that all processing, starts at the very edge, and that data is processed, understood. We get insight from it. And that insight is thus made available to anybody, anywhere, using some form of cloud deployment. I'm going to poke at one particular part in traditional HPC for AI, and that is that HPC is very good at running simulations. It's very good to build models and let you simulate environments. There was a fairly terrible case when a certain manufacturer of an automated vehicle managed to run over somebody pushing a bicycle. And that's because their models understood bicycles, they understood people, but they didn't understand the superposition of a bicycle and a person. And therefore the model failed. And consequently, the car just ran them over. Now, AI in cars is still, much safer than regular people driving, but it only takes one car to run somebody over, and the Luddites are out. But HPC can build those simulations. It can provide examples. It can provide simulations to aid with training. It can provide simulations for things that you're not going to do. It enables you to build a world of possibilities and lets you gain more training hours using simulated data. And this is particularly useful for aircraft simulation, for AI, for cars. And so I think that a large component of AI is the HPC simulation that gets rolled into the training. The bigger the machines, the more accurate the simulations, the finer resolution, and the more data we can have.
Okay, thanks. So, Mark, as the director of a major supercomputing centre, what do you see? How do you see the role of traditional supercomputing in AI? And then, furthermore, can I ask you, given that we're talking about the UK strategy, do you think an HPC strategy and an AI strategy, do you think it's one strategy for the UK, or do you think they're separate strategies?
So I think you have to separate the delivery of the infrastructure that we need to do AI at scale and HPC at scale in the UK from strategies around making sure that the UK has both a research activity in AI, which I think is really important and which the UK has led on for the last 20, 30 years, from the practitioner strategy of AI. In other words, the people that are using that work in frameworks to use the algorithms to develop trained data sets, etc., so that you can then infer answers to the data that's presented. And we quite often muddle these things. It's absolutely clear to me that the technologies that will be inside exascale computers will work really, really well for AI applications. But the one thing the HPC community needs to learn in this is that we need to think about data and data flowing into and out of our HPC systems differently from how we've thought in the past. AI is nothing without data, whereas an HPC system running a model is in fact just like a telescope being pointed at the skies. It's just producing data. That's its primary aim. So we need to think a little bit about it. And I also think the UK, in terms of its strategy for AI, needs to think jointly about the research side and the practitioners. Who is going to use this? How will our industry use it? How will our scientists use it? And without that strategy being clear, I don't think the UK will succeed in AI. It's got to be both.
Okay, so Ben or Daniele, as representatives of global companies, would you like to come in here and add your views?
So, we talk about investment in HPC. One of the things that we do is when we look at how we design systems, and not just systems, solutions is probably a better word. If we're looking at the movement of data, then we have to ensure that our systems allow the movement of data. If we go to, say, Germany, they're able to clearly articulate what it is they want and how it fits in with their strategy. If we go to the UK, I'm sorry to say at the moment, is, what Mark was alluding to is there isn't a 3-year, a 5-year strategy that says these are the problems and we need to find solutions for them. And by not laying out the requirements roadmap, it's very hard for a technology company to invest and to produce the machines that best fit those requirements. So you tend to go to countries that have that longer range view. We don't just design a supercomputer. It doesn't just appear, pardon me while I throw that away. It doesn't just appear. They take design. We have to look at technology, and they take between 3-4 odd years to come to fruition. And so we need those conversations. We need to have them, and we need to make sure that we're aligned. And if the UK government had those strategies, had those alignments in place, then it enables us to work better with the UK government to provide them the systems and solutions that they need.
Right. I'll come back to you in a minute, Ben, for a follow-up question. Daniele, is there anything that you would like to add from the ARM perspective about about how ARM could benefit from closer interaction to help with the design?
Yeah, of course. So I think it's very important what Ben said. So it's really key to start from the need, the business need, the social need, and then from there design the system and build actually the infrastructure needed to deliver that goal. So ARM is a bit different in terms of how it works, because we don't actually build system, we don't design system, we design IP that our partner use to build their own system. So in our case, the time scale is even longer, because what you design today, it's basically what our partner will work on in a few years, and you will see the actual product another couple of years down the line. So it's really important in terms of co-design, understanding which are the need and how we can phase it together with the most appropriate architecture.
Okay, so I'm going to go back to Ben, because I think you said something very interesting there. So my next question is going to really be about the role of government in the UK in the HPC and AI sector. So I think one of the points that you were making was it's not just about money. It's really about strategy. So would you like to elaborate on what you think the important things for the government to be doing over the next year, 3 years, 5 years will be to put us in a better position?
Yes, I think having a vision, a long-term goal. The US DOE set a goal for machines 3 years out, that at the time that they had this vision, we couldn't build them. And so we had to look at technology, suppliers, partnerships, and do research to enable us to look at the future of these machines. And as such, we will be supplying Aurora, Frontier, and El Capitan to 3 of the DOE labs at the end of next year and in 2022. So we are driven by those goals. So the UK, I think, could do itself a lot of service by setting itself aggressive goals. And from those aggressive goals for computation, for science, pulls along with it the technology. You're going to get an increase in communication infrastructure. You're going to get an increase in the number of people and jobs that are going to be able to have to use these machines, use them efficiently. Industry is going to have new goals. And so therefore, by being bold and having, taking the exascale science case, the industrial case, and saying, we will have this type of deployable technology within 2-3 years, preferably 2 rather than 3. But by saying that, then causes the ecosystem around that to have to start moving, to having to start getting ready. We're going to have to start building better models, better software. And those little projects that come out of that are crucial, I think, for UK industry. One of the things that I think COVID-19 showed us was that, yes, we had the money, but we couldn't just go and buy stuff, So I think within supercomputing, clearly there has to be money. But if you don't have a goal and a vision, and that goal and vision, extends 3, 5, 10 years, then you'll never get there. If you look at I have to be careful here. I want to be politically correct. Archer 2 is late. Had there been a goalpost that said, this is what everybody else is doing, then we need a machine here, 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 and here, then people would know that. The budgetary systems would know that. The expertise would know that. And we would continue to grow. I think it's the old adage, if you don't know where you're going, then any way is fine.
Okay, so Mark, would you like to comment?
Yeah.
The centre director.
Yeah, well,
or a personal viewpoint.
So there are a vast number of points there, right? So first of all, I think there is a hope that UKRI, the research councils, are going to have a plan in future, and that we know the route to that plan. They've got a director of research infrastructure, James Hetherington, who's been appointed. I'm supporting him in my role. But from a centre director point of view, I see all of this as well, in as much as I have to invest in a new power supply for an exascale system. You know, I'm putting in 2 30-megawatt wires at the moment, 60 megawatts of power. That takes 2.5 to 3 years to do. I'm building a new data centre room at a cost of £20 million. But I'm doing all this just in the hope that the government selects me to host the system, right? Those are big amounts of money to be playing with because we don't have a plan. And I think we need that side of plan on the infrastructure side, but on the other side, we need the science and then the industrial research plan. And we've tried to do that in the context of exascale with the science case that's coming along with the exascale business case. And that science case challenged our scientific communities and industrial communities to say, what would you do if you had an exaflop by a certain date? And that is absolutely the approach we need to take in future.
Okay, and finally, last but not least, Daniele, what do you see? How do you see the role of government?
Well, of course, I mean, I agree with what Ben and Mark said. I think that role of government is key in this kind of field, not just on the financing side, but also for roadmap and giving a direction into what we want to achieve. So I will not add much other than that. I think they got a really good point.
Okay, so we're into the last couple of minutes. I think we've had a really interesting discussion. So I'd like to give everybody sort of 30 seconds to say what do they think would be their key take-home message to people listening to this session. So who'd like to go first? Since I'm putting you on the spot.
I'll go first. I'd like to see a vision, a 5-year plan. I'd like to see what Mark alluded to, science being made interesting, core to the UK, engineering capabilities, and to get engineering and science in the UK and ask them, what would you do with an exaflop? It's coming.
Okay. Mark, next. You ready?
I think what I would like to see is to not spend a lot of my life in resource allocation meetings. I would like our scientists and our industrialists to be thinking, I have access to this fantastic resource. This is what I want to do in it, rather than think, I'll need to apply for time. Just get on and do it. That will show real innovation.
So you're looking to lower the barriers to people getting
absolutely
access. Great. Daniele?
Yeah, maybe seeing a different approach where I don't look for the system, for the peak power, but I look for the goal. What is, I want really to start from the social and the business goal, and then from there design what I need.
Okay, well, sadly that's us out of time. So thank you very much, panel. I think it's been a great discussion with lots of interesting views.
Want access to more CogX videos? Subscribe now for free at cogx.co.